Good afternoon to everyone present. Hope you are hearing me.
Yes, sir.
Okay, yeah. Welcome to today's data science meetup. And our theme for this today, 6th of May 2022, is exploring artificial neural networks today. And today we have our facilitator that is already around, and he will join us and he would be speaking to us shortly. So now today is May 6th, and let's talk a little bit about our facilitator, one of our speakers that we have. His name is Victor Aquino, and is the founder and CEO of VNodes Technology Limited, data-driven product development and marketing agencies that innovate, create, and support with digital experiences and professionalism that grows beyond exceptionally and help brand communicate strategically and effectively in a way that captures customers' attention, creates customers' attention, and drive series. Nelton Communication for OTP Technologies Limited, which are both tech-driven companies. Due to his passions for technology, most especially artificial intelligence and software engineering, academic research and African business growth, and economic expansion, he is contributing to the development and advancement of African languages at Massachusetts. I'm correct in the pronunciation of that. At Mastercard, a grassroots organization whose mission is to strengthen and support natural language processing research. He has a well-developed and managed over 10 softwares that provide solutions to business problems and comfort the customer's pain points. A bookworm, as fondly called Victor, has received academic awards in his careers and has participated in both academic and tech competition, where he emerged one of the best. And these are a little bit about our speaker for today's event, Mr. Victor Aquino. Mr. Victor Aquino, if you are around, please, you can start speaking now. Mr. Victor. Mr. Victor, if you are trying to talk, your this thing is muted. You can unmute yourself to speak. Okay. Pending the time that Mr. Victor gets pending the time Mr. Victor gets set, let us have our second speaker speak. Mr. Mohammed Yakini, you can speak.
Okay, good afternoon, everybody. Can you hear me?
Yeah, we can hear you. Can go on.
Yeah. Good afternoon, everybody. Thank you for having me. And today would be talking about a topic that is very interesting and a bit complex, if I would say. So I would want us all to pay a little more attention as to what we are going to be relating today as to the topic involved. And as well, we'd like to have this presentation in a more unveiling manner. So we'd take it a step at a time, just for the sake of beginners and intermediate level data scientists available. Then we'd later have a deep dive as to what the topic entails. So without wasting so much of our time, I'll be sharing my screen quickly to give an overview and as well an introduction as to what we are going to be talking about extensively today. Just a minute. Yes, I hope we can all see my screen now.
Yes, we can.
Okay. Just a minute. Okay. Okay. So yeah, today we are going to be going through this very important topic, and it has been a topic that has been coming up in the data science world recently, and we as members of this industry wouldn't want to shy away from this topic. So today we are going to be exploring artificial neural networks. So my name is Mohammed. Just for those that don't know me yet, I'm a Python developer here at Bincom Dev Center, and I would be unveiling artificial neural networks to us while we wait for our external speaker to have a deep dive as to what artificial neural networks are. So yeah, I'll be going over a few things, and one of them will be an introduction to artificial neural network, what is deep learning, and as well we'll have an overview as to the history of neural networks and how they emerged. We'll also know how this neural network works and the reason as to why, artificial neural networks, the application of these neural networks, and we'll be concluding this side of things so that we'll be able to deep dive into the technicalities as to neural networks. So yeah, I immediately would like to start with a basic analogy as to why neural networks, or as to what are the things that inspires neural networks. So just like we have birds actually inspires us to fly. And, being that birds fly, it had actually inspired a lot of scientists to think of other ways to make things fly. So we have aeroplanes these days, we have helicopters, and we have other invention, that were inspired by just the way birds fly. Not just birds, we also have whales. So scientists, by studying whales, they were also inspired to build a submarine, right? So we have a submarine that acts more like a whale. It goes deep down the sea or the ocean and is able to function properly, at that depth of things. So studying the whales also inspired submarine and countless more other inventions that were inspired by nature, right? Nature is a good source of inspiration, if I would say. All of these things were inspired by nature. So it's only logical for us to think about things with our brain and derive an inspiration from that. So all of this thinking gives us the inspiration on how to build an intelligent machine. We might as well just think of something innovative or something that will solve a lot of problems, and merely by just thinking that in our brains, we can derive inspiration on how these things might work. So the key idea that sparks artificial neural network, however, not just planes or helicopters were inspired by birds. They don't have to flap their wings, right? So when we have these inspirations that birds can allow us to build something that would fly, we don't necessarily have to completely simulate what a bird can do. We don't necessarily have to build something that can flap their wings, right? Similarly, artificial neural networks have gradually become quite different from the biological connotation. So I'll be in no time briefing us as to the inception of artificial neural network and how they all started and where we derived the term artificial neural network. Furthermore, some researchers have even argued that we should drop, the biological analogy, that has been attached to artificial neural networks. So we say neurons, right? So some researchers have argued that we should rather refer them to units as to neurons, so that we wouldn't be restricting our creativity to biological plausible systems alone, So that's basically the idea as to how we get inspired by nature and how our brain, comes up with an architecture as to build intelligent machines with our imaginations. So artificial neural networks are a very core of deep learning. As we all know, as data scientists here and as those that are not data scientists, we are exposed to the topic of machine learning. We are also exposed to the topic of deep learning and artificial intelligence. All of these are subfields of each other. So artificial neural networks are the very core of deep learning. They are versatile, they are very powerful, they are scalable, and they make, it ideal to tackle large and highly complex machine learning tasks. Examples of all of these tasks, if you can imagine them, are classifying billions of images. For example, we have Google Images. So on Google Image, we have thousands and millions of images that come through, by the time, by the hour, or by the minute. So these are large set of data that are coming in. So deep learning and artificial neural networks, are very powerful to be able to handle all of these billions and zillions of images that comes to Google. Not just Google, we also have speech recognition services such as Apple Siri. So Apple Siri, it's a recognition service that acts as an assistant to most of us on our devices. This Apple Siri service handles a lot of queries and a lot of input from people. For it to successfully handle all of this input and queries from people, it has to be built on a very highly complex algorithms. And in our case, artificial neural networks. So we can see how artificial neural network helps even the top tier tech companies to handle billions and thousands of data. So without wasting too much time as to this, would be heading over to what deep learning is. What is deep learning? I know for beginners here in the house, would be asking ourselves what deep learning is, where does deep learning come from, and how does it work? So this is a brief introduction as to what deep learning is and where deep learning applies to all of these that we're talking about. So deep learning is a specific subfield of machine learning. It takes on learning representation from data that put emphasis on learning successive layers of increasingly meaningful representation. And what do I mean by that? When we say deep learning, just like we have it with machine learning, it's a method at which machines learn. We feed machines with data and we feed machines with input, and we tell this machine, learn from this input so that in the future, you would be able to make proper predictions for us. So applying deep learning, which is an advanced method of machine learning, is a method at which we are not just saying, okay, understand these data better. That's not what deep learning does. It isn't a reference to any kind of deeper understanding. We are not saying the machine to understand this data that we are giving it deeper, right? All we are telling the machine to do is to have an idea of successive layers of representation. So if the machine can represent a data in one layer, deep learning would aid the machine to be able to represent these layers, this data, in successive layers of representation rather. So how many layers contribute to a model of data is called the depth of a model. So when we have a model that gives us, successive layers of representation, we can now say that this model has a depth to it. Similarly to how we learn from experience, deep learning algorithm would perform a task repeatedly, and each time tweaking it a little to improve the outcome. So what do I mean by this? Just like we human beings, we do learn from experience. The very moment you learned your first line of code, print hello world, and moving forward to the moment at which you write complex algorithms, complex functions and classes, you acquired all these skills over the time. You were experienced enough to be able to come through some errors and learn from those errors, So moving forward, you would no longer be battling with errors just like the way you did when you just started out. Same thing as deep learning algorithms. The more we feed them data and the more they keep layering our data, with different representation, they keep learning, as long as this data comes in. And every time they shoot an output, they keep tweaking, this output to better improve our outcome. So that's basically how deep learning works. So we refer to deep learning because the neural network have various depth, layers that enables learning. Modern deep learning often involves tens and even hundreds of successful layers of representation, and they are all learned automatically from exposure to large amount of training data. So that's deep learning for you. And just like we mentioned earlier, artificial neural networks are a very core of deep learning. So now we understand how deep learning works, and we can now move further as to how artificial neural network works, or rather how deep learning make use of artificial neural networks, to build a more highly complex algorithms. So before we go over as to what these neural networks are and how they work, we would like to have a brief history as to the inception of neural networks. So interestingly, artificial neural networks have been around for quite a while. They were first introduced back in 1943 by a neurophysiologist, Warren McCloch, and a mathematician, Walter Pitts. So both neural networks was invented by these two scientists, the mathematician and as well the neurophysiologist. So they presented a simplified computational model of how biological neurons might work together in animal brains, to perform a complex computation using propositional logic. Sorry about that. The model is a very simple neural network using electrical circuits, and this was the very first artificial neural network architecture. So what do this mean? So these scientists, Warren McClock and the mathematician Walter Pitt, actually presented a model that works same way as the biological neurons work in animal brains. So we are all animals. We are high-level animals, humans. So our brain work in a certain ways. We have neurons in our brain that receive signals from each other and tell us what to do. So just like the way a brain works, these two scientists were able to come up with a model replicating the same way a brain works. So the whole idea of this is to have intelligent machines in the future that will be able to think, or that will be able to be intelligent just like the way human beings are intelligent. How wonderful that could sound. So these two scientists further went to present this model. And also in 1949, Donald Hebb wrote The Organization of Behaviors, a work which pointed out the fact that neural pathways are strengthened each time they are used, a concept fundamentally essential to the way in which humans learn. So this was a presentation as to the organization of behavior, how human beings think about stuff in their head and how they behave to these things. So these are the analogy that will be transferred to an intelligent system so that that intelligent system can work just like human beings. So over the time, we have had artificial neural networks being presented to the science industry, and we've seen over the time how the science industry have received these presentations from various researchers across the world. So the early successes of artificial neural network until the 1960s led to the widespread belief that we would soon be conversing with truly intelligent machines. So just like I explained earlier, artificial neural networks will be in place or will be trained in such a manner that they can be intelligent just like the way human beings are intelligent. They can think just like the way human beings can think, and they can process things just like the way human beings can process things. So in the 1960s, there was this belief that we'd soon have intelligent machines that could think like humans. And that was quite exciting for a lot of people, and as well researchers. So progress on neural network research halted due to fear, unfulfilled claim, and the likes. So unfortunately, the progress on artificial neural networks was stalled because there was this sense of fear and unfulfilled claim, yes? And all of this was caused due to critics from a lot of people around as to how neural networks will affect us in the future, So the result was to halt much of the funding, because at the time, there were a lot of funding to artificial neural network research. People were making research, and there were a lot of funding. People were funding this research. So when this progress was stalled, there were no more research or funding to the research of artificial neural network. In fact, the research itself and funding went drastically down, not until in the 1980s. So in the 1980s, there were a revival of interest in artificial neural network, or as well the study of artificial neural networks. So they were like a new architecture, which were further invented and better trained to be developed. So all of these started happening at the 1980s, but the progress was quite slow. And by the 1990s, other powerful machine learning techniques were invented. So while there was progress with artificial neural networks, there were other inventions as to other powerful machine learning techniques, such as support vector machine, SVM. These techniques at that time seemed to offer better results and stronger theoretical foundation than artificial neural network. So slowly, these inventions were about to beat artificial neural network, and that was quite worrisome. So at that time again, the study and the research of artificial neural network went on a very long winter. Like, there were no talks about artificial neural network again, because most scientists had adopted the neural forms of machine learning techniques, such as support vector machine, which up to date is still a very popular machine learning algorithms to explore. So finally, we began to witness yet another wave of interest in artificial neural networks. Just like we have it on the diagram by our left, we have seen the various periods at which artificial neural network was invented, and as to the period which it is now, and the interest as to why we should use artificial neural networks in modern technology. So with this wave, die out, just like the previous one, just like we said, there were times in the past where artificial neural networks, died down. So the question now is, this wave, this new interest of artificial neural network, will it stay longer? Will it die just like it did in previous time? Well, there are a few good reasons to believe that this wave will be different from what we had in the past. And I will be talking about these good reasons as to why this wave will be quite different. But similarly, before we go over that, let's have an overview as to how this neural network works. So the term artificial neural network is derived from biological neural networks. So before we entirely talk about artificial neural network, let's even have a quick look at biological neurons. The term is artificial neural network. So there's what we call biological neurons, just like I highlighted in the beginning of this presentation, that animals, likewise as higher animals, human beings, we all have biological neurons in our brain that helps us process a lot of things. So just like the way we are listening to this presentation right now, we have several neurons in our brain that tells us to focus on this presentation. And as well, there are other neurons that might as well send signals for us to be distracted from this presentation. So this is how biological neurons work. So how do they work technically? So these neurons, biological neurons, are found in animals' cerebral cortex. That's our brain, right? And they are composed of a cell body containing the nucleus and most of the cell's complex components. So just like we have a cell body, this cell body contains nucleus and other complex components, and even many branching extensions called dendrites. Just like we have it on the diagram, you can see where the dendrite is located, plus a very long extension called the axon. So this axon is a very long extension in our cell body that is a lot lengthier than even the cell body itself. In fact, some axons are up to 10 of thousands of times longer than other complex component in this cell body. Near the extremity of the axon, it splits off into many branches called the telendoral. And at the tip of these branches are minuscule structures called synaptic terminals, or simply synapses, right? So which are connected to the dendrites or directly to the cell body. So we have the synapses which are connected directly to the cell body, and they are located at the very tip of the axon. Not to forget, we just said the axon, is a lot lengthier than every other component in this cell body. Yeah. So what happens to all of this? We've mentioned a lot of biological terms. What happens to all of this? How do this work? So when a particular neuron receives sufficient number of signals from other neurons within a few milliseconds, it fires out a signal. So we have a neuron here, and when a neuron keeps receiving a lot of signals from other neurons, it fires up its own signal, just like we have it in the human brain. Sometimes we might not know we are feeling hungry, right? But when we start having dry mouth, or we start yawning, a signal is being sent to our brain, telling the right part of our brain for us to know that we are hungry and we need to eat. So these are the ways these neurons work. So a particular other neuron would have to send signals to them for it to fire up its own signal. So a particular neuron is telling another neuron that we are hungry, and another neuron is telling us that we should eat. So these are the way these things work. So furthermore, we have seen how biological neurons work, right? So the earlier scientists that we mentioned, Warren and Walter, which are both neuropsychologists and a mathematician, they further went to propose a very simple model of the biological neurons, which later became known as artificial neurons. So they were the inception of artificial neurons entirely. They had to build an artificial neuron, just like I highlighted in the beginning of this presentation, that these neurons that were invented were done by these wonderful scientists, So how do the artificial neurons that Warren and Walter built work? How do they work? So it has one or more binary on and off inputs and one binary output. So the artificial neuron simply activates its output when more than a certain number of inputs are active. So they actually shows that even with a very simplified model, it is possible to build a network of artificial neurons that computes any logical proposition you want. So anything you can think of, any complex situation you can think of, you can simulate that using artificial neural networks. So just like we have the diagram below, we have the neuron A and C, right? So neuron A gives neuron C 2 inputs, or as well 2 signals. So the moment it gives neuron C 2 signals, it activates neuron C. And once neuron C is activated, neuron C actually fires out an output, right? So we also have by my right, we have neuron A and B and C. So we have neuron A sending signals to neuron C, and we also have neuron B sending signals to neuron C. So neuron C is now activated and it can fire up or fire out an output, By the right as well, we also have neuron A and B sending, up to 4 signals to neuron C. So neuron C now receives 4 signals, which is more than enough to get neuron C activated. And neuron C is now activated. Neuron C can then fire out an output. Similarly,
on the last diagram, we have neuron A and B. So neuron A fires out 2 signals to neuron C, whereas neuron B does not fire any signal to neuron C. So what happens in this situation? Neuron A has already given neuron C sufficient input for neuron C to fire up. So that's basically what artificial neural network is and how they work. We also have more complex and technicalities as to how this neural network works. I'm very hopeful that our second speaker would really have a deep dive as to how this neural network works. And we'll also be seeing concepts like input layers, hidden layers, and output layers. So this is what basically what an artificial neural architecture. Yeah, so we have input layout, just like I explained earlier. Neurons receive inputs, right? And when they receive inputs, they output, a result. So we have input layout. These are layers in which input comes in, the neurons. And we also have hidden layers. These are layers that processes these inputs, and as well, they send these inputs to the output layer, and this output layer thereby gives us the results that we want. I wouldn't be taking so much time as to that because we don't really have the luxury of time. I believe we'd have a better explanation as to how this works, on our next presentation. So moving forward, would go over as to why we should use artificial neural network and how important they are. So the amount of data we generate every day is staggering. Currently, it is estimated that we generate up to 2.6 quintillion bytes. I don't know if anybody has heard of quintillion, but yeah, that's how much data are being generated every day. And it's the resource that makes deep learning possible. So just like we highlighted earlier, deep learning actually works on a large amount of data. So having this amount of data being generated every day has given deep learning, or as well artificial neural network, the liberty to be able to function properly in modern technology. So since deep learning algorithms requires a tons of data to learn from, this increase in data creation is one reason that deep learning capabilities have grown in recent years, right? So there's now a huge quantity of data available to train neural networks. And artificial neural network frequently outperform other machine learning techniques. I know we'd have that question in our heads that, oh, why neural networks? Why can't we make use of the existing machine learning techniques? So due to the fact that artificial neural network outperforms other machine learning techniques on a very large and complex problem, that gives us a major reason to explore artificial neural network. Even when using a data set that is very diverse, unstructured, and interconnected, the more deep learning algorithms, the better they perform. Sorry, can you excuse me? So yes, moving forward as to why artificial neural network is important, the tremendous increase in computing power since the 1990s now makes it very possible to train large data neural networks in a very reasonable amount of time. So the computing power has drastically increased since the 1990s. So which leaves us, the luxury of exploring artificial neural networks. So we'll be able to train large networks in a reasonable amount of time. This is due to Moore's law, and but also thanks to the gaming industry. So with the rise invention of different games and how powerful they can be and how powerful they will require data, and as well and how powerful they will require GPU cards by the millions, it has given a rise as to the exploration of artificial neural networks. So these neural networks would also have the ability to be able to handle, such large computing power. So training algorithms has also improved, right? But though, to be fair, right, they are only slightly different from the one used in the 1990s. So just like we highlighted before, in the 1990s, there were some artificial neural network that was proposed by some scientists, right? And these scientists, are taking their time to build these neural networks. So the neural networks we are having now are fairly slightly, or I would say slightly different from the ones that was proposed in the 1990s, But these relatively small tweaks have a very huge impact as to artificial neural networks. So moving forward, the human-like properties of neural networks and the ability to perform tasks in combination with infinite sequence makes neural network uniquely suitable for today's large database application. So we now have businesses and top-tier tech companies that make use of a large database application. So it has become more important for us to explore these neural networks for us to be able to perform tasks, with infinite sequence. So neural networks also have their own ability to understand ambiguous, competing, and incomplete data, right? So we might have such kind of data that are ambiguous, that are incomplete. Sometimes we call this fuzzy logic, right? These are ambiguous, competing, and incomplete data that might be very difficult to handle, right? So neural network have the ability to understand even that side of things. So even if an accurate model isn't available, it's a controllable process. You can use it. So yeah, we've had the reasons as to why we should use artificial neural networks. So we'll be going over to the application of these neural networks. I know we are all curious as to how they are being applied, or what are the use cases as to artificial neural networks. So today, neural networks are revolutionizing businesses and everyday life, right? And how do they do so? They are bringing us to the next level in artificial intelligence by emulating the way interconnected brain cells function, right? Neural networks, which are aliased as NN, enables machines, including smartphones and computers, that we use on a daily basis. So these computers and smartphones that we use on a daily basis are now trained to learn, recognize pattern, and make prediction in a humanoid fashion. And what I mean by humanoid in this side of things is a manner at which humans make predictions. So our machines will be able to, or our devices will be able to, make prediction in that manner, as well as to solve problems in every business sector. I think would also have a more in-depth as to how this works in large-scale businesses. I'm pretty sure our next presenter will be judicious with that information. Now, we are in time when machines can learn to solve complex problems without human intervention. What exactly are the problems that we are tackling? Here are just a few of the tasks that deep learning support today, and the list will just continue to grow as the algorithms continue to learn via the infusion of data. Yeah, so some of the examples of the applications of artificial neural networks. So we have virtual assistants. So virtual assistants, just like we have it, we've seen various versions of virtual assistants, whether it's Alexa, whether it's Siri, or whether it's Cortana. The virtual assistants of online service providers use deep learning to, or as well artificial neural networks, to help understand your speech and the language humans use when they interact with them, right? So we also have visions for driverless delivery trucks. We now have trucks that deliver stuffs to people that are driverless. We have drones, just like we have them around. We have camera drones and all sorts of drones, and autonomous cars. These are cars that have been automated, self-driving cars, just like we have it with Tesla, right? The way an autonomous vehicle understands the realities of the road and how to respond to them, whether it's a stop sign, a ball in the streets, or another vehicle coming along. All of these things happen through deep learning algorithms. So you are very sure that when you have a complex deep learning algorithms, your autonomous cars will be able to detect all of these things. It sees, which brings us to the topic of object recognition and the likes. The more data the algorithm receive, the better they are able to act human-like in their information processing. Knowing a stop sign, just like we said, covered with snow, is still a stop sign. I think our algorithms will be more intelligent than that in the future to be able to recognize if a stop sign is being covered by snow. So we also have chatbots and service bots. So chatbots and service bots that provide customer service for a lot of companies are able to respond in an intelligent and helpful way to an increasingly amount of text questions thanks to deep learning. So yeah, service bots or chatbots, which most businesses, or as well, especially e-commerce businesses uses this day, now acts more like a customer service for a lot of their customers. So customers can head up to chatbots and purchase products from an e-commerce site. They can as well make queries, complaints, and all of those. So with deep learning, the increasingly amount of text questions that come into these bots can be handled intelligently and in a very helpful way. So we also have facial recognition. So deep learning is being used for facial recognition, not only for security purposes, but for tagging people on Facebook posts, and we might be able to pay for items in a store. How interesting that could be just by using our faces in the next feature. Well, I hope so. So the challenge for deep learning algorithms for facial recognition is knowing that it's the same person, even though they have changed their hairstyle, or they've changed their clothes, they've shaved off their beards, or if the image taken is poor due to bad lighting or an obstruction. So yeah, these are some of the very good examples or applications of artificial neural networks and the very use cases of them. So would be concluding this presentation, just like I highlighted before starting this presentation. This presentation is supposed to unveil this topic, from scratch to finish. So this is more like an introduction as to how neural network works. We also talked about the applications of these neural networks. We saw the inceptions of these neural networks, how they have been incepted from biological neurons. We also saw as to how these neurons work. We talked about input layers, hidden layers, and as well output layers. So yeah, in conclusion, real-world business application for neural networks are booming. So in some cases, neural networks have already become the method of choice for businesses. I'm very sure that most businesses have been in recent time adopting neural networks, So yeah, it gives them the edge for fund analytics, marketing, segmentation, and fraud detection. So neural networks have a very unique ability to extract meaning from complex data to find patterns and detect trends that are too convoluted for the human brain. So just like we are humans, our brain get exhausted sometimes. So we might not be able to compute things properly sometimes. So these are why we have neural networks to simulate how our brain works, and they'll be able to handle this complex computation that our brains cannot handle. So neural networks have provided us with greater convenience in numerous ways, including through ride-sharing applications. We have Gmail, smart sorting, and suggestions on Amazon, amongst many, many other things. So yeah, this is a wrap as to neural networks and how they work. So would be giving the floor to our next presenter to be able to take us on a deep dive as to how this neural network works, basically and technically, as well as the types of neural networks, how to train in neural networks. I know there might be questions as to how this works, the implementation of these neural networks, some of the algorithms and how it's connected to machine learning, and all of these technical stuffs will be discussed. So thank you very much for your time, and I hope we all had a more enlightening session as to these neural networks.
Yeah, thank you for that presentation. And we are quickly, because our time is past, we are going to move on to our next speaker. We have already introduced him already. So please, if you have any questions, you can put them down in the chat box, and or we wait to the end of the next speaker that is going to come and speak for us. So the next speaker can come and speak now. He has 25 minutes to talk with us. Thank you. Mr. Victor Aquino, over to you, sir.
All right. Yeah. Good afternoon, everyone. I want to believe you can hear me clearly.
Yeah, we can.
Yeah.
All right. Thank you. Thank you so much for that wonderful presentation, Mohammed. Yeah, I actually learned a lot during your presentation. But can you just please stop sharing your screen so I'll be able to present my. Mohammed, are you there? Can you all hear me?
Yeah, we can hear you. Mohammed, please, can you stop sharing your screen?
Mohammed, please stop presenting so I can present from here.
Yes.
All right, thank you so much for that. Sorry. I would basically be quickly coming. Can we all see my screen?
Yeah, we can.
Okay, all right, thank you so much. So I would first of all appreciate the management of Income Dev Center. So thank you so much for giving me this kind of opportunity to speak here. So I don't trivialize. Thank you so much as much as that. For the previous presenter, Muhammad, thank you so much for that wonderful presentation. So yeah, the topic before me is exploring artificial neural network. So, and just because of our time, I will quickly be rushing through it. Despite the fact that I don't really have something too technical. So, and my slides are quite relatable. I mean, the content in my slides are quite relatable. So, it's something we can all relate to. So, I wouldn't be going to technical because I learned that the audience I would be communicating with today might not be people that really want the advanced thing. So then I had to just prepare something between beginners and intermediate. So and Mohammed has actually spoken on some of these stuff. I mean, some of the things I prepared. So thank you so much once again. So let's go right into it. So we have the content. So I will be talking about the introduction, and under that I'll be talking about the background of studies, the layers of neurons, the differences and similarity between the ANN and the BNN, both the artificial and the biological. So then knowing what artificial neural network really entails, so the why, the how, the when, and the who, and at the same time, knowing the types of artificial neural network, the career opportunities, learning the techniques, and all. So yeah, let's continue. So the introduction. So according to mathworks.com, a neural network, which is also called artificial neural network, is actually an adaptive system. So, and that learns by using interconnected nodes or neurons in a layered structure that resembles a human brain. So, what basically this means is that it adapts. Or so, because when Muhammad was presenting the other time, he talked about artificial neural network being a subset of deep learning. So, and deep learning being a subset of, machine learning. So I think the whole thing is just like inside artificial intelligence, we have machine learning, inside machine learning, we have deep learning, and inside deep learning, we have, artificial neural network. So it is an adaptive system. I mean, it adapts with environment, it adapts with what we come, what is coming, I mean, what would actually come in the future and all. So, and, the way it was made model just like human brain. So as Muhammad said, he said something that we can find the birds inspires us to fly. So, and it was the human brain that inspired those that really started, or let me just say those that pioneered this idea, I mean, to start something on that. So that is that about that. So we can see the biological processes in the brain, and at the same time, the artificial neural network. Can we say that they look alike? There's a kind of look alike, something between them, because we are having the biological processes. We realize that it's in form of this kind of interconnection and trying to create several nodes, and moving from one node to another. So, and when we're talking about node is just like a point of connection, right? So then via maybe two or more cables, in electrical installation, and and in electronics basically. So we say a node is where two or more maybe wires or something are connected. So it is basically just like that, but in this case we are talking about neurons. So, and there are nodes, there are points where they are connected, and the points where they are connected is just like a normal, I mean, it's just like a store. I mean, some of those nodes are just like a store that we're going to consider as we continue. So basically, we will realize that there is a quite similarity between them, because this one is having a chip, right? So, and from that chip, there is a lot of interconnection trying to go, broadly, and trying to grow widely, as, let me just say, as far as we can, make it, or as far as it can. So, this is just, the kind of similarity between them. We realize that truly it was the human brain that really inspired, or let me just say that brought about the birth of artificial neural network. So if a brain could be connected in that way, how can we try as much as possible to create an artificial one, that really works like human brains and all. So a neural network breaks down, the input layers of abstraction. So these are just like maybe functionalities level. So, in computer system, we have several abstraction layers. We have maybe the problem statement, the algorithm part, the part where you have to maybe draw your data flow, do a lot of things. So these are just layers of abstractions, and each of these abstractions are connected with a particular route that perhaps we may not want other users to see, all right? So if we are creating an algorithm, or we are creating a layer for a problem statement, and we are trying to, maybe just because we're trying to do something, it's just like maybe, inside that problem statement, we might still have a kind of algorithm that solves it, and inside the algorithm, we might have some codes that really solves it. So that is just how, how it's being represented. So it's just like we don't know what happens when we, try to turn our gear to gear one or gear two, but there is a kind of layer of abstraction where we can see that, okay, fine, I'm currently at gear one, I'm currently at gear two. So, but in depth, we may not really know. It's only the mechanical engineers that can actually say that. So, and it can be trained using many examples to recognize patterns, patterns in speech, patterns in images. So basically, I mean, artificial neural network is a very, very good, a very good concept, or let me just say a very good branch of deep learning. So, and it really, really helps most especially when we are talking about the pattern recognition part. So, and some other parts, maybe, we have several parts like segmentations and all. So, artificial neural network can really, really, really help us. And most especially when we are trying to network, maybe from one point to another and trying to create a kind of connection, sponsored, should I say sponsored by a particular way? So, because, the strength of that connection is just like the width. And our model in the long run works depending on the width in that particular connection, or let me just say the width in that particular network. So, it's something that can be improved on in the future, and it can be improved on, or let me just say it would work consequently in the future based on the width given to each of those nodes, or let me just say each of those connections. And when I'm talking about the width, I'm actually talking about the strength of each connection. So it might actually be a kind of hierarchical thing, or perhaps a sort of priority coming in. So then we have several layers of neurons, and one of them is we have the input layer, all right? So we have the hidden layer and the output layer. Muhammad spoke on this, but I will only say that input layer is where the inputs are actually coming from. So, and if I would make the hidden layer relatable, I would call it maybe the processor, or perhaps the engine that really processes the whole inputs coming in. So, and that is where the output is being generated. So, and but at the output layer, we have our predictions. So, and we have the differences between our computer and human brain. So, we can say that our biological neurons or nerve cells have, our brain have biological neurons or nerve cells, and our computers rather use the silicon transistors. At the same time, for human brain, we have 200 billion neurons and 32 trillion interconnections. 32 trillion, just like 32 trillion nodes. And at the same time, for the computer, we're having about 1 billion bytes RAM. So, and a trillion of bytes on disk. So neurons consume, neurons size is around, or let me just say neuron sizes are around 10 to 6 meters. So, and this one is having, the other one, which is that of the computer, is having 10 to 9 meters. So, and talking about the energy consumptions, the human brain consumes around 6 to 10 joules, while that of the computer goes for 10 to 16 joules. So, for the learning capability, a kind of learning capability, because that is one of the things trying to create similarities between them, because they both learn, right? So, and what they learn from basically is just, the data. So we learn from data to right from childhood. Maybe when we're in the kindergarten, we're told A is apple, A is for apple, B is for ball. And right from there, even if we were lied to, that is what we've actually conceived as a conception. And that is what we still, we still know today. So if anyone comes in the future and tell us that, no, A is not for apple, A is for ball, we'll be like, wow, what's wrong with you? From my childhood, I've gotten to know this. So then for human brain, we have the learning capability. We learn basically from real life, we learn from experiences and all. And while, that of computer, computer learns from the programming. So we can say the programming capability. So, this one has the capability to learn, let me just say, in a raw way, and this one will have to feed on programs. So, artificial neural networks, which is ANN, and biological neural networks. So considering the speed, artificial neural network is actually faster in processing of information, because, this is an artificial thing, right? So we can always look for a way to improve the system. So we realize that we've graduated from, let me just say, from big because let me put it this way, we've graduated from, let me say, big hardwares into even small and smart hardwares. And we realize that in the whole engineering process, one of the things we are trying to improve is that we are trying to, number one, improve the space. We are trying to improve, the speed at the same time. So because we don't want it to be big and at the same time we want it to be faster, all right? So it is something that, research is being conducted upon and a lot of improvement are being done. Consequently, subsequently, and the research will not still stop. So, and for human part, which is the biological neural network, so that is slower in processing information because it has been like that since our creator has created us, right? So, the response time is in milliseconds, all right? So, why milliseconds? That should be around, that should be around 10 raised to the minus, if I'm not wrong. So, and for nanoseconds, that's 10 raised to the minus 9. So we realize that that of the artificial neural network is quite faster. So then for the processing, we have the processing for artificial neural network, and for the biological neural network, we have the parallel neural, massively parallel processing. So for serial, when talking about serial, is like a kind of thread, all right? So that is straight. So then once this is done, it passes this to this. After this, it passes it. So, and with the way those things are quite networked, we could be thinking that series, something in serial should be slower, right? But artificial neural network is still quite faster. But for biological neural network is massively parallel in processing because you can be doing a lot of things concurrently. You can be doing a lot of things simultaneously. So that is why it is actually in parallel. So then for the size and complexity, so the less size and complexity, that is for artificial neural network, and it does not perform complex pattern recognition tasks. Despite the fact that a lot of improvements are being done lately, right? But even with that, there are still some. I'm coming. My network is unstable. There are still some complex tasks that it can still not perform. So then, for the neural network, for the biological neural network, a highly complex and dense network of interconnected neurons, contain neurons of the order of 1011 with 1015 interconnection, strong. So then, for the storage, information storage is replaceable, is replacing new data with an old one. So you can always bring out this and put another one. But for the other one, so instead of replacing, you can always just expand that kind of, the knowledge base. So it is quite dense. It is highly complex and dense. So, and and the a kind of dense network of interconnected neurons containing neurons of the order, as I mentioned earlier, of 1011 with 1015, interconnection. So then for the fault tolerance, one is fault intolerance, and the other one is fault tolerant to a large extent. So which means the artificial neural network, once it's gets some faults, that's why the fact that we are trying to improve fault tolerance of systems, but even with that, they still have limit, right? So then for it can actually corrupt, the data corrupt a lot of things if the whole thing is quite faulty, because it is not really, when being subjected to a lot of faults, then it can actually lead to a long-term damage, right? Or perhaps permanent damage that you may not be able to, that it may not be able to recover from. But for the other one, information storage is adaptable, means new information is added by adjusting the interconnection strength without destroying old information, all right? So, and the next one is we have this kind of the control mechanism, because all of these things are still quite similar to, let me just say, they are just like a control system. So the control mechanism that actually guides the whole control process. So one of them is that there is a control unit for controlling computing activities. We always have a control unit for that. So there are no specific control mechanisms external, mechanisms external to the computing task. So we can say that this is the main, despite the fact that we always say that our brain is the processor, our brain, but even with that, if we can, I can't start digging deep into biology now, but if we dig deep, we realize that there is no exact, specific mechanism that really controls the whole computing task. Okay, fine. This is because even what the brain does basically is being fed. There are some other parts of the body that feeds the brain some data to work on, and that is when the brain will realize, oh wow, this is what I'm meant to do, and this is what I need to do, and perhaps it sends a response, right? So it's in form of a kind of request response thing. So then the artificial neural networks, the ANN and biological neural network similarities. So then for the similarities, the neural networks resemble the human brain in the following two ways. A neural network acquires knowledge through learning. They both learn. So then in neural networks, knowledge is a store. As I said earlier, I said we were coming to this. So it's a store within interneuron connection strength, known as synaptic weights. So then what this means is just that, like, each of these the neural network knowledge is just like a kind of knowledge base within, what's it called? The neuron connections. Where those neurons are actually connected. So interneuron connection strength. So the strength then, and it is quite known as, the synaptic weights. So then, for the synaptic weights, so it refers to the strength or amplitude of a connection between nodes. I think I mentioned that earlier. So then it's actually corresponding in biology to the amount of influence the firing of one neutron has on another. So then if when Muhammad was presented the other time, he was showing us how the neuron A fires at B, and B fires at C, and perhaps that's that kind of create a sort of interconnection, and that would determine what let me just say A fires at C, B as well fires at C, and C would know what to do with that, right? Or perhaps maybe there are two firing inputs coming from A and nothing coming from B, and C would still work with will still work with whatever it was given. So basically, there is basically, let me put it this way: there are a lot of, there are several ways of doing the connection, right? But the connection strength is what is being referred to as synaptic width. How each of them, how each connections weighs more than each other. Okay, fine. I think this weighs more than this, and a kind of priority might be said, okay, fine, for this to have weight more than this, then this might have more more benefit for me, then that might be a reason for me to process this first, sort of. So, and there is a particular man, John von Neumann, so that are actually try to work on a kind of architecture that consists of a single and a shared memory for programs and data. So where there will be a kind of interfacing between the memory, and at the same time, as you are taking the input, sending into the memory, processing it, and also then, and for programs, I just wish I could show us the charts, but I don't have it here. So then, and data, a single bus for memory access, an arithmetic unit, and a program control unit. So if we see the chart, we're going to see there. So the von Neumann processor operates and execution cycles seriously. So that is how it goes continuously. So it fetches the instruction, then it executes, it fetches, as I said earlier, gets the inputs, then processes it. So fetches in the instruction and executes. So then there are quite similarities between, kind of differences between them. So von Neumann is serial, while ANN based computing is parallel. So, and at the same time, von Neumann actually functions logically with a set of if and else rules, like a set of conditional rules, like, okay, fine, if this, then do this, else do this, or if this, do this, else if this, do this, else do this. So, but this one functions by learning pattern. So this one really learns from a particular pattern from a given input. So whether image, text, or video, or speech, audio, or anything. So then the next one is programmable by higher level languages such as C. So then we can see that von Neumann can be programmed with languages like C, Java, C++, YANN. In essence, the program itself, because it's actually reading from a kind of pattern. So then next one, von Neumann requires either big or error-prone parallel processors, while ANN-based computing requires a kind use of application specific multiple chips. So, and we can see that when the chip when there's a kind of interconnections, or let me just say multiple connections coming into the ship and perhaps going out of the ship, trying to show what how the whole thing so then the basics of artificial neural networks, I think I've said this a bit. So we have the inputs, we have the outputs, and we have the neurons, or we call it perceptron. So the input is the source fed, the data. The output is just like a kind of prediction being generated. And the neuron, that is the basic unit of every neural network. So it accepts and generates what? And generates the prediction. So knowing what neural network really entails. So then why do we have neural network? Why neural networks? While artificial neural networks. So then we have neural networks are also ideally suited to help people solve complex problems in real life situations. They can learn and model relationships between inputs and outputs that are non-linear and complex, make generalizations and inferences, review hidden relationships, review hidden patterns, and even predictions. So because let me just cite an example with that. In the application of neural network on let me say for social media applications, social media basically, we realize that it can really help us to just know how a particular user is doing, what his performance are. It can help us with this kind of sentiment analysis. So maybe you really want to know how a product really works. People saying about that kind of product, oh wow, maybe when it gets things like this product is bad, maybe the word bad, then it should cluster, or let me just classify it as maybe a negative sentiment, a negative feedback, right? So, and perhaps when you see anything like the word good, maybe the product is good, the product is nice, the platform was quite swift and fast. So then, you can always try to use. So then these are just reasons why artificial neural network, is really, let me say, why it really came into existence, why it came into existence, because there are a lot of patterns that, it might take human beings sometimes to just recognize. How about just trying to, run some models with a particular data and, trying to get the input and the output? The artificial neural network will really tell you what relationship is being established between them. So, and at the same time, it would really tell you maybe what patterns, what predictions, and the model is actually highly volatile and and highly volatile data rather. So, and such as financial data. So, and variances needed to predict rare events such as fraud detection. So, and maybe when something like that has happened, or when you've studied this, and this. So then, because you have the output already, and you're actually feeding, you have your actual output, what the output looks like, and you are really feeding in an input. You really want to know if the input coming in is really aligning with the output you have already with you. And if it is aligning, then you tell it to do whatever it needs to. Maybe once you realize that a particular credit card, details are being imputed maybe twice, thrice, or let me just say in 4 times or something, then you should flag it as, being fraudulent. So then these are just things that can really help us. I mean, these are ways artificial has really been so helpful. So let me just say that is one of the why, or let me just say the major why it came into an existence. There are a lot of things we need to, we need them to do. So there are several things here. So I think I will talk about them in the future. So then the how does it work? A neural network on several process layers, and we have several layers as mentioned earlier. So using simple elements operating in parallel. So and the network consists of an input layer, one or more hidden layers, and an output layer. All right. So as I explained, so then because there will be an input layer where the input is coming from an hidden layer that processes and generates the prediction, and the output layer that processes and supply the prediction, and the output layer that really generates the prediction. Then the next one, we have the and life, the who. Yeah, so then who are those that really need artificial neural networks? So we have the health industry and life science industry. So then the organization use neural networks to enable predictive diagnostics, and at the same time biomedical imaging and health monitoring. So where they get to know that you find maybe you come to the hospital today and they get your data, they know what is wrong with you. Maybe they've stored that particular image, and perhaps maybe when you come next time, or maybe when another person comes and they the input, they've actually gotten some sort of data, and they perhaps analyzed it, gotten an output. Okay, fine, this is what must be happening to this particular group of data, or let me just say to the particular group of data points. So, and when another input is being supplied to that kind of model, and the model try to perform a sort of computation on it, and it was just like, fine, wow, I think this really aligns with what we have. So then this person as well is having the cancer, is having this, is having that. So, and at the same time, it can really help even an individual to where your data has actually been so stored, and perhaps maybe kind of analysis has been done, and an output, let me say a prediction has been generated already. So, and at the same time, so when an input is coming in, perhaps maybe a new thing or something similar, then you can, a prediction can be made that, wow, due to the fact that we've actually recorded this in past times, or due to the fact that this has happened, the kind of analysis we've done, the kind of results we've got, then this should be what should be similar, or let me just say this is similar to that, and this should be the output, this should be what is wrong. So we use it in the manufacturing industry too. So these are people, or let me just say these are industries that uses it. So the energy, the manufacturing companies, so they use neural networks to optimize their supply chains, automate defect detection, and forecast energy needs. So the banking industry uses it well too. So, and banks use neural network to detect fraud, as I said earlier, so conduct credit analysis and automate financial advisor services. Yeah, so they can always automate that. Then, when I was talking about von Neumann architecture the other time, so I was saying that it actually uses a kind of if-else, structure, let me just say model, or conditional statement sort of. So for the other one, so that one that one really uses the kind of model itself. It doesn't. He eats himself. I'm coming. Let me just quickly try to navigate there so we can get that properly. So yeah, for the von Neumann was I'm coming. So yeah, von Neumann was using a kind of if-else statement. I'm coming. I'm not even getting that again. Sorry, I don't know. Maybe just because I'm quite in haste, I don't even know. Let's continue. So then, it uses a kind of conditional. Okay, fine. Once this has happened in past times, and this has really, this is coming up again. So then, this is what what the prediction should look like. This is what the result should look like, because all of these data are being fed. Data. So are being fed, and since they've been fed, and a kind of a kind of result has been gotten before, or a kind of prediction has been gotten, or perhaps you've actually created this kind of, maybe you've created a kind of, how do I put it? Yeah, you've analyzed your stuff and you've given it something that, okay, fine, if something like this comes for due to the classification, or let me just say due to the kind of group of data points we have in that particular segment. So when we're talking about classification, clustering, and also we can always talk about that. But due to the fact that, okay, some sources like things like this are happening due to this, then since an input is coming in, then something like that should happen. So then it can actually advise. So in as much the response is similar to what an output has actually given maybe in previous times, then you can also say, okay, fine, due to the fact that this thing has happened in past times, and due to this, due to this, then we can tell you that this, what you are about to do is quite fraudulent, or perhaps maybe you are trying to run into a scam. You shouldn't do that. You should prevent yourself from that. So I just hope we get to understand that better. So then, the public sector uses it too. So then they use neural network to support smart cities. So the security, intelligence, and facial recognition. So where you put your face there, and it gets to recognize your face. Okay, fine. This is this person, and I think Facebook uses that kind of algorithm, and maybe so I don't think Facebook still uses it, but there was a time when you maybe you snap a picture with somebody and that particular person is on Facebook, it tags the person automatically because it gets to read the whole what's it called, the pattern of that particular face, and at the same time try to recognize that, wow, this is Victor. So then Victor should be tagged in this particular post, or in this particular maybe image post or something you're making. So, and at the same time, it is used in security, intelligence. It is used to build smart cities, intelligent cities and all. So it could be used in the retail industries too. This is quite similar to the manufacturing. So it is used in retail. So, and at the same time, so it is used, neural network is used to power conversational chatbots, enhance and deepen customer intelligence, and perform core network analysis. So yeah, the customer intelligence is there. It can actually help you deepen the customer intelligence and at the same time enhance it. So because there are lately we have a lot of conversational chatbots almost across. I can say maybe perhaps 50% of web applications now, because they are trying to automate some stuff instead of human beings attending to you. Then they might have programmed not that they might have, the chatbot would have been programmed to even respond or answer you to a reasonable extent before a human being can come. So I mean, a human being can respond to you. So then when does this emanated? I mean, when did this emanated rather, or when did this emanate, or when did it, when did we give birth to this? Yeah. So let me put it that way. So we are having the first artificial neural network was invented in 1958 by psychologist Frank Rosenblatt. So as Muhammad has spoken about that, so I shouldn't dwell so much on that again. So then he worked on something called perceptron. So, and it was intended to model how human brain processed visual data and learn to recognize objects. So eventually someone realized that in addition to providing insights into functionality of the human brain, so ANN could be a useful tool, or it could be useful tools in their own right. So they can actually help you in this kind of pattern recognition thing, and try to solve more problems even apart from what Frank Rosenblatt was trying to do. So then we have several types of neural network. We have the convolutional, we have the recurrent, we have the feed forward neural network, and we have the autoencoder neural network. So then for the convolutional, so this contains like 5 types. So we have the inputs, the convolution, the pooling, the fully connected, and the output. So the convolution there is just like the kind of real building blocks, like the kind of filters that need to be learned during the modeling process. So then we have we have the recurrent too. So this one uses sequential information such as time-stamped data. So time-stamped data are just like data that, okay, fine, this is the exact, I mean, it has a particular time that, okay, fine, this was the time it was generated. So it uses information, sequential information such as time-stamped data. So then maybe this data was generated on this on so date by so time, this on so date by so time. So, and from a sensor device or a spoken sentence composed of a sequence of times, unlike traditional neural networks, all inputs to a recurrent neural network are not independent of each other. So definitely they are not independent of each other. They are not standing alone. So they are quite dependent on each other. So, and the output for each element depends on the computations of its preceding elements. So then basically recurrent neural networks are used in forecasting and time series. So in time series applications, they are used in sentiment analysis. I mentioned that earlier, where you can actually use that to get a sentiment about a particular product, or maybe about a particular service that has been rendered, or about a particular thing. So you want to know what feedback you are having. Are they good? Are they bad? And for other text applications, it can be used too. So therefore, I'm so sorry, I'm quite too fast. I'm just trying to ensure that I meet up with the time. So we have the feed-forward neural network in which each perceptron in one layer is connected to every perceptron from the next layer. It's just like a particular perceptron in this layer is connected to every perceptron in the next layer. So then information is fed forward, is actually going forward from one layer to the next in the forward direction only. There are no feedback loops in feed forward neural. We have auto-encoder networks, and they are used to create abstractions called encoders. So, and at the same time, it was created from a given set of inputs. Although similar to more traditional neural networks, autoencoders seek to model the inputs themselves, and therefore the method is considered unsupervised. So just because they try to do some stuff themselves, they are not supervised. Once you give them every necessary data they want, but for supervised, it is not like that. And autoencoder neural network is an example. So career opportunities in that. So I spoke about the use of this chatbot thing. So, and chatbot is being developed mostly by who? By software engineers, right? So, and software, because there are even several machine learning packages that you can use. I mean, in PHP, in Python, and several in Django, and several languages and frameworks like that. So you can always use artificial neural network is applicable in software engineering. It is applicable in the field where you can actually try to create a sort of stock market description. So you can I mean that can even help you with this kind of maybe in the forex market, you really want to know what is happening. I mean, due to the fact that this happened, that happened, so then this would happen, and due to past events, this has happened in past time, and this is similar thing is happening now, so then definitely this will not result well. This is what would happen. So it can be used in social media, as I said earlier. In aerospace, that one is even wide. So it can be used for a lot of things in the aerospace too. So, and at the same time in the defense industry. So for the aerospace, so it can be used for fault diagnosis. It can be used for high performance autopiloting. So it can be used for the securing the aircraft control systems. And I said that even it can also be used for this kind of modeling key dynamic simulations, for some key areas, in the aircraft industry. So, and at the same time, we have the defense. So then for the defense, we all know that defense is the backbone of almost every company, every country rather. So, and due to that fact, so neural networks can also help us shape the defense operations, of technologically advanced countries like USA, Britain, and all. So then it can be used in the healthcare industry too. So because the modern day individuals are basically leveraging on the advantages of technology that are provided in this sector already. So and convolutional neural network can basically be helpful in that because it is really, really actively healthcare industry for this kind of X-ray detection, CT scan, and ultrasound. So, and the same thing for the signature verification, weather forecasting, and all. So we have the supervised learning and supervised learning. I've spoken about that. Supervised, you give it every data it's needed. I mean, it's needed for you to make for you. So for the unsupervised, so you can use the input data to train the network whose output is what is known already. So then this network classifies the input data and adjusts the weight, I mean the strength of the connection by feature, then extraction in the input data. So we have the reinforcement learning, which happens to be supervised, and the output value is unknown in that case. Provides feedback on whether the output is what is right or wrong. So and for the next one, we have the offline learning. We have please provide the slides. We have the offline learning. We have the online learning. So for offline learning, the weight vector adjustment and threshold adjustment are made only after the training set is shown to the network, and it is also called batch learning. So then how to start a career in neural network? One of the things you need to do is to have a good knowledge of mathematics, most especially calculus, linear algebra, statistics, probability, all this logistics regression, and this distribution, and also just have the knowledge of them. So programming too is very, very essential. You need to know how to write codes. Maybe you want to write write Python and any other programming language that really supports this. So the specific prerequisites are considering, while considering AI and AI, artificial intelligence, machine learning, deep learning, and neural network technologies. So then there are, there is a kind of integration that we can sense between them. So then having the knowledge of a few of technologies algorithm, having the knowledge on a few technology algorithm will always, also prove to be extremely helpful, very, very helpful. So, and some of these can include the linear regression, the logistic regression, the k-nearest neighbors, that is the KNN, the k-means clustering. So then, we have another thing, which is, all these activation functions, the back propagation, the learning rate, the epochs, and more, the kind, even weight biases, having that kind of knowledge will really help you to pick up this kind of, to pick up a career path in artificial neural network. So you can as well learn, try to know as many as you can different libraries, so such as TensorFlow, Keras, PyTorch, Theano, and all. So for the conclusion, every researcher in the field of neural network technology should have a strong foundation in what's it called in artificial intelligence. So, and at the same time, the machine learning, deep learning, as I said earlier, are quite interwoven. Artificial intelligence give birth to machine learning give birth to deep learning, and deep learning give birth to neural network, artificial neural network. So a deep dive essentially requires an in-depth, intensive study, most often through short courses provided by strategic professionals. So you can also get that online. Try to lay your hands more on several things, mathematics in the mathematical part, the special prerequisites, the things you need to know, all of the, try to know the kind of CNN, the kind of model you want to use, maybe the artificial neural network model you want to use, the type you want to use, maybe you want to use the recurrent, you want to use the convolutional. So you need to have the knowledge of all of these things before you can say you are choosing a career path there. Or let me just say as you go, or let me just say as you grow, then you get to learn more about everything. So thank you so much. I've come to the end of the presentation. So I'm so sorry I really, really rushed things just because of the time. So thank you. Thank you very much, Mr. Victor. So can anyone hear me?
We can hear you, sir.
Yeah, we can hear you, sir.
Okay. So thank you very much, Mr. Victor. Thank you very much, Mr. Mohammed. So are there any questions for the speakers? Any questions? If I can see a question in the chat for Mr. Wisdom. Okay, you said, sir, as a software developer interested in neural networks, how would you advise one to navigate his way to become a ANN engineer? I don't know if this question is being directed to. So, Mr. Wisdom, who is this question being directed to? Oh, okay, can you hear me?
Yes, I can hear you, sir.
Okay, so if I can get the question very well, like as a software engineer, how can you navigate your way into being an artificial neural network engineer, right? Is that the question?
Yes, sir.
Okay, all right, thank you. So basically, because now let me just say languages, they made it every software engineers. So if you're starting, maybe you want to you are going into software engineering, let's say maybe web, all right, so and perhaps you are using Python and maybe Django as your framework. So there are several frameworks responsible that always use. So, and even in PHP, I mean, if you are a PHP developer, so and perhaps you are using frameworks like maybe CodeIgniter, frameworks like Laravel or Cake PHP. So most especially Laravel, there are several packages, several libraries that has been made available for anyone that really wants to start something in that particular industry. So I can say it is quite easier compared to before. So all of this stuff has actually been developed. So you just need to tap into them, just get the library and use them. So if you now want to transition, if you're referring to maybe you want to transition from being maybe from being a software engineer to being an ANN engineer. So what you just need to do is because software engineer might not require a lot of mathematics, mathematics knowledge, or let me just say a mathematics background. So the only thing you need to do is get your hands on on mathematics, on several mathematics that has to do with most especially machine learning. So then try to learn more, most especially probability part. So try to learn probability, learn statistics, lay your hands more on, all of those things and try to know how they work. So, and from there, lay your hands on several libraries like PyTorch, like Keras, like, several of them. So try to know what each of those libraries do. So try to know what each of those libraries do. Like NumPy is even very, very popular, Pandas. So then we have several of them. So after you've known the mathematics, and for the mathematics, you don't need to dwell there so much, all right? So you just need to learn the basis. So once you've learned the basis, so that by the time you're getting predictions, you will know what is really, really happening. You will know whether you have to use, and even when you want to do something, you yourself, an instinct will tell you that this thing I want to do, logistic regression will not work. Linear regression might not work. So I think I can use this. I can use multiple regression. I can use this. I can use that. So that kind of background would really help you. So, and after that, then you can now transition into really running, big models. I mean, trying to run several models with big data and all. So then with that, due to the fact that you have the programming experience before as a software engineer, it will really help you to learn faster. So the programming part might not really be an issue, but you need to focus more on the mathematical part and how to use several libraries that are provided by some of these languages that really supports you to, run ANN models like maybe CNN and all. Thank you. I don't know if I answered the question.
Yes, sir, you answered it, sir. Thank you, sir.
Okay, thank you, sir. So are there any other questions?
Okay, I have a question.
Okay, you can go ahead.
Yes. There's this gap between the theoretical aspects of all these algorithms and the practical aspect. For instance, you would see a PhD owner on data science that knows all the everything that is involved in all these ANN machine learning codes and all these algorithms. But when it gets to the part of implementing, they really do not have a knowledge about it. And we know quite well that all these algorithms actually comes from the theoretical aspect. For instance, you can see that the whole idea of machine learning and everything, ANN, actually started with a paper that was presented some years ago, and actually it is what we are building on. It seems like in this present dispensation, is either somebody focus on the theoretical and leaves the practical part, the implementation part. And I just want to know what the speaker's view is on this thing. Like, how can we just bridge that gap? Thank you.
Okay, all right. Thank you so much for the question. So actually, that is a question relatable. So I currently belong to a community, a Masakane. That's the name of the community. And basically what we are trying to work on is we're trying to, we are really working on NLP, natural language processing, and we are revolutionizing African languages. So, and on the team, we have people that are very, very sound at mathematics. I mean, both the theoretical part. We have people that they can really, really sit down and run the code. We have people that even after the whole thing, it is the encoder that they can work with. I mean, the sound parts, how the waves are doing, how each of them really works. So then we have it severally. So one thing is, it might be quite impossible for you to have the deep knowledge of everything. So because if you get to Google, if you get to Facebook, you realize that Facebook hired some professors that basically what they can do is just to pick a pen and try to write things down for you. So then they will now call the engineers that will be like, this is what I'm trying to say, this is what we need to do, this is what we need to do. And they will be the one to pick from what they've done. All right. So then because if you want to really synchronize the two, what would happen is that you have to go deep in the development process, I mean, the programming part, and you have to go deep in the research parts too. So instead of just writing papers and all, you will just focus, I mean, you will be writing paper and at the same time be running models, running a lot of things. But how do we bridge the gap? So the best way to bridge the gap is just to learn it. So the word learning cannot be overemphasized. All right, so we can give it time, even despite the fact that it might be quite impossible for us to be very, very sound, very, very in code, very, very sound in the two, but we have to just give it time, I mean, to sit down and learn the whole thing. So we need to give more time to programming, try to know how to bring the principle of each of those models into programming. So I think that's just the best way to really, really bridge the gap. So you give yourself to learning and you give it time so that you can grow.
Okay. Thank you very much. I think I just wanted to contribute to that. I think Mr. Victor has actually said it all, but just to add up to that, while trying to bridge that gap and employing people to learn about these skills, practical skills as to how this works, it will also be an addition if we explore other AI-related, artificial intelligence-related projects. So exploring those kind of projects and the grand scheme of things will give the availability of those skills to be learned and as well will give the availability of more involvement. So I think generally the ecosystem in Africa, I don't know if I will get this correctly, but the tech ecosystem in Africa is quite small, I would say. I don't know if there are statistics to that, but I believe it's quite small. And as well, most of the novel projects that are being worked on in the African space are centered around a particular ideology. So we have rising innovations in fintech, we have rising innovation in software development, but I think there's a gap as to cut-edging projects that has to do with artificial intelligence and all of this deep learning that we learned. Yeah.
So, and one of the ways, let me quickly ask something. One of the ways to outgrow that is to join communities. Yeah. So if you, instead of you trying to sit down and, rack your brain to learn all of those things yourself, if you belong to a team, or let me just say a group of people that are knowledgeable. So if you have somebody that really knows more of the practical and what you are is just, you are just a professor with this kind of, both the archaic, new, novel knowledge of the whole thing. So what you just need to do is to get yourself familiar with that kind of person. So know how they're doing it, because that's one of the things I do. So currently I can write the code, right? But I'm still, I've not even gotten my master's, all right? So there are I've never featured in any, in more than 3 papers, 3 publishing papers, so not more than 3. So then, and we have people that they have published like 17, 16, 20, 30. So if you can get yourself familiar with them, they can always put you through. Or and that kind of learning path will be quite faster than you trying to pick up the whole thing from by yourself. So most especially if you are a developer, if you are in the practical side of it, it's really, because you know how it works already. Once you run it, you'll be like, wow, this is what is happening in this model. Despite the fact that you may not know the in-depth, but you will still have this kind of knowledge, or let me just say surface knowledge of how the whole thing works, right? So if you now get yourself familiar with somebody that has the in-depth knowledge, then it would really, really help you. Yeah, thank you.
Yeah, thank you very much.
Yeah, thank you very much. That was insightful, honestly. And okay, a quick one before Mike goes. I think just like Mr. Victor has highlighted, would also love it if we are being recommended to these groups where we can interact with bright minds as to all of this, because it's now becoming very inevitable as a data science practitioner not to be able to acquire those analytic skills and thinking and mathematics and all of those. So if you could recommend these communities, because we fairly enough, we've seen some communities on social media, Facebook, LinkedIn, and all of those, but most of these communities are just fairly available, just like the way they are. So would like to have recommendation as to these groups where we can easily interact with bright minds.
Okay, are you trying to say that there's an existing group or what, like that people should join, right?
No, like I was just seeking for your recommendations as to.
Okay, my recommendation. Okay. Oh, sorry. Yeah. So actually, for basically, I mostly specialize in what's it called, in NLP, which is natural language processing. Mm-hmm. So and in NLP too, there are several things we do. So there's this kind of community I can recommend, which is a community that is really, really helping the African languages, even right from the grassroots. And that is Masakane. Yeah, I belong to the community, and it has really, really helped me. So, and we have another one. We have Kokui. So we have Kokui. So they specialize in several things too. most especially natural language processing. So when you are dealing with the speech to text, the text to speech, so there are several things there. So, and Koku is basically creating several models, that people can actually, that people can use. So you can try that out. So you can try out Kokui, you can try out Masakane. So do I have another one? So I think those are the two that came to my head at the moment. Yeah, those are the two that came to my head. So, and get yourself connected with PhD students, basically. We that are here, we are more familiar with with the coding part. All right. So get yourself familiar with PHP students, most especially people that are doing PhD outside this country.
Oh, wow.
so so if
I
you
think you have a
network yourself,
reservation for that statement.
if you network yourself with them, it will really, really help you. To be very honest, I have somebody in Germany, and the person has really, really helped me to grow. You get it now. So, and through him, I've gotten connections to, with several people too. Even there are white men and also. And once they see that maybe you are quite you are quite curious to learn, and they can see the Ghana is there. This kind of network would keep being broadened. All right. So I just realized that you are getting to know more from people. Know people from one person, know more from that particular person too. So there are several communities. You can also search online. So if you are able to join, so just try as much as possible to join. They will really, really help your growth.
Yeah, that's amazing. Thank you very much for that.
Okay, so I'll quickly, running out of time. I'll quickly have to do some presentation. So,
Please be quick with it. Just like summarize it. Don't like go through everything. Just summarize it. Thank you. Because time has gone. We are entering into the emigrate people's time. Thank you.
Okay. So we are going to look at the services being contact center, who are the organizers of this data science meetup. So we have different locations. Locations virtually near you. We have Atiaba, Ibadan, Kano, Kaduna, and Ijebode, Warri, and so many places. So Bincom Dev Center, some of the services they render Bincom Academy, Bincom Tech Internship, the Bincom Tech Apprenticeship, Bincom Community Events / Projects, Lightspace, Bincom Global Tech Program, the Emigrate, the Bincom Mentoring Platform, Labs by Bincom. And so Bincom Academy is a place where we have a facilitator and students, where we have intensive training program where the facilitator takes these students in a 4 weeks intensive training and takes them on the curriculum and knowledge track. If you want to know more about it, you can check bincom.net/academy. We have the Light Space, is a place where you come have if you want to have some seminars, conferences, and get together. It's just a space where you could have some seminars and all that. We have the Bincom community events and projects. So we have Bincom community events / projects is a geared and giving back to the community and building the tech ecosystem. It focuses on informing and exposing the youth to the current technology trends and how to prepare for the future. So we have different Bincom community events. They are divided into 5. We have the masterclass, the meetups, idea sharing, explore on the move, and challenge and brainstorm. So we have the Bincom Tech Network. Bincom Tech Network is on Slack. It's just for collaboration purposes, interaction with facilitator and other participants. We have the Bincom Tech Club. It creates an ecosystem that enables tech enthusiasts who has little or no knowledge on tech to learn and rub minds with tech experts. We have the meetup. So we have the PHP meetup, cloud hosting meetup, Angular meetup, digital meetup, and the data science meetup, which is one of the meetups we're having right now. Laravel and Yi meetup, DevOps meetup. So for the master classes, we have the Bincom Startup School, Social Lender, Digital Financial Services Masterclass. technology enhanced learning, Income ICT career talk. This the idea sharing series. We have the Income ICT career talk and be great open day. So we have the Income Global Tech now. Tech now and you pay later. So the Income Global Tech program will cover 1 to 2 years, which will cost 1.2 million, but you can be paid later instrumentally through the income sharing agreement. So Tolu, am I supposed to play the video or I should go on?
No, don't play the video. Just move on to the end. Just go to the
Okay.
end. Yeah, time is already going. Just go to the end now. Go to the end. Go to the end.
Okay,
Yeah.
so if you want to contact us, you can visit Bincom Dev Center at hello. Hello.
You are breaking. We can't hear you.
Okay, can you hear me now?
Yeah, so yeah, just please round up.
Okay,
We are
okay.
already past time. Thank you.
Okay, so if you want to contact us, I say you can visit www.bincomdevcenter.com or call the number on your screen. So thank you.
Yeah. All right. So we've come to the end of today's community event. Thank you all for joining, and we'll see you at the next event. Thank you.